So hello, everyone. Good afternoon to those of you from EST or similar time zones. We are excited to have you all aboard for the final Spring 2021 event, Fun with R. This is co-hosted by Our Ladies East Lansing and Our Ladies Chicago. On behalf of East Lansing, me, Stephanie, Kayla are here. Camille is not able to make it today. And we have the Chicago co-organizers, Ola and Abby. So welcome again. And today we have actually a lot of fun topics, quite appropriate with end of semester. Andrea will be talking to us about sambaR. She'll tell us more about it. Stephanie will be talking to us about a package that's going to play some fun music when your code finishes running. Kayla is going to talk to us about personalized map art, and Sneha is going to talk about a wrapper for the chess package. So with that, I would say we can get started. Let me stop sharing my screen, and Andrea, you can.
Good morning, everybody. Thank you very much for having me here. And I am going to share a link for slides because even if it's fun, I cannot not do slides. And I am going to talk about a small package that I call the sambaR. I hope you're all seeing my slides. And just to tell you quickly, thank you for being here and thank you for the invite. I am just going to introduce myself very quickly. I am a biologist. I am a Colombian biologist. I went to Brazil to have my graduate student. So I have a PhD in botany from the Rio de Janeiro Botanical Garden. And I work with, when I'm not doing other things, I work mostly with biodiversity informatics and some community ecology and quantitative ecology. And I am a user. I use R since 2009, and I belong to the Rio de Janeiro chapter since 2017. And working with Our Ladies and working with R for these days has made me very interested in open and reproducible science and data feminism. And with this, we've co-founded a small initiative that is called the Libre, that holds for the Independent Lab of Biodiversity Informatics and Reproducibility in Ecology. And the acronym works in Spanish and Portuguese, it just doesn't work in English. So in Libre, we just sometimes teach R and we do some small projects, but sometimes we do things like we teach grad course about data analysis, and good practices in data analysis. But today I'm going to talk about only sambaR. This is a package that comes from the fact that my native language is Spanish. So that means you grow up trying to understand what music in foreign languages happen in the radio. And so this is part of a very common thing that we do all the time. It's like, what is the lyric? Because we don't even sometimes know the lyrics. And also, what does it mean? And this happened when I went to Brazil and I started learning Portuguese. There was so much new music, and the interaction was telling your Colombian friends that Brazilian music is awesome and trying to translate in the back, and also telling your Brazilian friends that Colombian music and what we listen when we grow up in Spanish-speaking countries, what we listen. So this has been a lost in translation situation all the time. And now I am here in the US. So I have to explain music from all the countries and try so translating music has been like part of the interaction, the social interaction all the time. And I was trying to show an American friend some sambas because it was Carnival, and I knew that the Genius packages exist. I don't know if you know that the Genius database exists. It has lyrics it's a large, huge database, and there's this Genius package. It was written by Josiah Perry, and it's amazing. It's already a fun way to play with art because it gets you lyrics and the albums, and it has stats and who wrote it, and it's just amazing to play with. And I knew that this existed, and I wanted to see if we could use some way to translate. And of course, Google Translator exists, and it can be used from within R. So Genius works like this. You just put the artist, the song, it's a huge package. You can do many, many things with it, but it has lots of music information. And what I do, like when I teach good practices of code, is that I create destination folders to save things. So I avoid repeating calls, and I want to make it everything organized in subfolders. So this is my way of having fun. But this is something that I did, like trying to make to save lots of lyrics for the musics. And the other part, the part where I try to translate the music, has this package. It's called the Google Language R, and it's you have to configure the cloud translation API, and this is something that was very it was kind of a nice step for me, because in real life, I am very afraid of APIs. Like these kind of interfaces, I'm a biologist. I do not lead well with some interfaces. So in real life, when they tell me that it's going to be via API, my first impression is like, I'm going to be afraid. So this was a nice way to try to not be afraid of them. So I discovered that you are charged by character when you configure your APIs. And so you have to avoid making repeated calls. This asterisk is for me to remind you that there's a free trial, so you're not going to be charged for it. But you still want to not make repeated calls, and you want to avoid to make same language translations. So English to English, you'll be charged. You shouldn't be needing to do it. And so I started with a series of scripts, and I had to configure the API. This has a whole part that I cannot show here, but I have the prints and I can show you later, and I will document this better. But after you configure the API, you can get to translate anything inside R session. And so I just kind of joined everything and try to use some tools that are newer, but I haven't had the opportunity to use. So package building with use this. I hadn't used use this, so it was like a good opportunity to learn, to see how it works, and to try to practice what I don't know if it exists, like Shiny skills. Like Shiny is super. I don't think it's an easy learning curve, but it was also a good way to learn a little bit of Shiny. So sambaR was one of all of these founds of sources of information and things. And so now it works like this, and you can do it, like I have just checked it. I hope it works. You can install it from our Libre repository. It's Libre sambaR. And it will work like this. This is what's needed. So it's exactly the code, how it works. It's like you just say what the artist is and the song is. And if you do not put a target language, it will just return the lyrics. But if you put a target language, such as English, for example, it will return a table with the translation in the front. And I will just try to make a small live show. I will show you how it works here. So for example, I am here in my R session. And if I will kill it, I will kill the session. So this was a way to kind of, I don't know, to kind. So I already installed it. So I just need to do library sambaR. I will just make this larger. And if you load and run the example, because of the API authentication part, it will automatically authenticate, and it works like this. If you have
I'm sorry,
the
are you
artist and the
showing
song,
the R Studio? Because we still
Yeah.
see the presentation.
I am, but I will just. I understand that I did. I understand that what I did was just showing one of the. That's my whole desktop. So this should work. Thank you. So thank you for saying this. So yes, I only did what the only thing that I did was like loading the package and run example, and we have this. this is a shiny. And this is the simplest of shinies, but this is a way to understand. And this is an example. So you have the artist, you can have any song, and sometimes it just doesn't work with special characters. Sometimes it works. I have no idea why. And hopefully this works. Could not find function translators. Do you see? Live coding is always like this. But I have it here. Library. And hey. It just like it just broke like today, like right now. But I will try to make it work. I cannot believe this. I just tested it. But this is a little bit of the idea. I will just try to show you how it works. But just to not let time go while I try to make it work, because I don't know what happened. I just want to say that fun is a little bit in the eyes of the beholder, like what we believe that is fun or not, it's just like very personal. So it's kind of you putting things into the air, like what do you think is fun is a little bit weird sometimes. And with our users, that happens a lot, like people just get into side projects that can be weird. But it's amazing, like to see how interests go and people want to use it. And that these curiosity-driven projects are very good to learn things. So I showed you how many different things were like put together in place. I swear I will make it work. But at the same time, I just wanted to finish with this. Like, sometimes the environment gets a little bit competitive, and it's like you have to do these kind of side projects to be good. You have to improve because you have. So I just don't let anyone like forcing this. So keep it fun and make it nice. And if I have a couple of minutes, I will just go back to the Shiny app because it does not make sense that it's not working. I don't know, Janani, do you have a couple of minutes here at least?
Yes, yes.
Okay, sure. So this is, I am going to make this work because
we started only at 1:06, so yes.
Okay, I just was running a little bit, but so now this has to work. But I didn't know if I put the chat. So this library, sambaR. My friend. And I will just load the Google language package. And as I told you, like this step is a little bit longer, but the package works if you don't have it yet, because it will take the lyrics. That's the Genius package. And it will work, for example. Now it works. Okay, so now you're seeing the Shiny app, and now we are going to make it. I will just use the example. And one of the things that I missed to say, because I am very into good practices of not repeating, I had said that it saves everything onto the I know what it is. I didn't load one package. I didn't say that it was a Genius package. And so it works. It saves everything to the home folder. I will just. I am so sad. I might have, and this happens a lot. Like I might have just tested with everything loaded, but so you don't know what the calls for the functions are. So I missed a Genius call. So when I tested, it didn't give a mistake. So it's okay. This is part of the fun. This is part of the mistake, but it will save here. So you don't get you don't have to go back to the API because it will be charged. So you will have the CSVs for the tables for the lyrics, and it has more information than the Shiny works. And it saves the different languages. So it should work still without the Shiny working. The examples in the slides are just knitting directly, so it's okay. But this is a little bit one of the things that we do. Yeah, that's it. I'm missing something very bad, but well, I will not be bummed about this. I will be a little bit, but I am open to questions if you want to, just because I did not miss this. So please, you can.
Feel free to raise your hand if you have any questions, or you can also throw it into chat.
Yeah.
Thank you so much, Andrea.
No, thank you so much. I am so, like, it was everything working. This is just one of these classic live coding things that I have no idea what happened. Like, it was
this happens to all of us. This is a really good package, and I'm sure we will enjoy trying it out.
And the thing is, I swear to you, it's installing and it's working. This is something in my workspace right now. So I will make it. Thank you so much for having me here anyway.
Absolutely. So the links to all the packages that we'll be discussing today, I will add that to our GitHub repository also. So please do check it out.
Yeah, sure.
Okay. So any questions for Andrea? If not, we can probably.
Okay.
All right. So if not, we can go on to the next speaker. Stephanie, would you like to go next?
Yeah, sure thing. Let me share my screen. Can everyone hear me okay?
Yep.
Great. So I just have a tiny intro, and then I'll get into the demo I prepared. So today I'm just going to go over Brooke Watson's package BRRR, and just a little bit about me before we start. I'm a computational biology postdoc at MSU. I got my PhD in neuroscience a couple of years ago, where I did a lot of data analysis and really sort of learned on the fly how to use R to do that, and really fell in love with the coding aspect. So that's why I wanted to get more computational experience in my postdoc. And I'm a hardcore cat lady, which will show up a little bit later in the presentation. And you might get some like live cat noises during this presentation, so I apologize for that in advance. But anyway, this picture is of a fortune that I got from a fortune cookie when I was in grad school that I had taped to my desk for the rest of the time I was there. And it just says, your ability to find the silly in the serious will take you far. And I really identify with that. I think, you know, when we're a little bit silly and we take ourselves less seriously, there's more room to explore and be creative. And I think some really cool stuff can come from that. And that's why I was really excited about the Fun with R demos today, and just the idea of having fun with R in general. So just to outline the demo a little bit, I'm going to show you how to use Brooke Watson Madubuonwu's BRRR package. And it lets a wrapper tell you when your code is done running, like Little John yelling, yeah. It's inspired by the BRRR package, which lets you use more conventional noises like themes from video games to let you know within your code. And I'll cover BRRR a little bit at the end. It works the same way. So I just wanted to sort of start out by saying how inspired I've been by Brooke Watson. She is a cool R lady, and she works for the ACLU, which is like a dream data science job. And she has this great blog where she goes through all of the sort of fun R projects she's had. One of them that we really like is the US of Bay, where she's tracked using Social Security data, she's tracked the babies named Beyonce since 1995. And you can see that they sort of peak around when a couple of her albums come out, and then go down from there, I think, as Beyonce really became a legend. It might be weirder to name your baby Beyonce, but anyway, she's really inspired me to sort of get my to sort of get a blog together and use sort of fun projects to learn more about R, which I think is really cool. Okay, so if you want to follow along, I recommend just heading to my GitHub page. I can add that to the chat. Where are you, chat? Sorry, sometimes the stuff goes away. Right, so it's there. And then you can just either, clone the repo, or the easiest thing may be just to download the zip file. And I have just the markdown file of the demo, or the actual, you can open the actual markdown in RStudio. Okay. So the first thing that you need to do is install the BRRR package. I have mine commented out because I've already done that, but we'll go ahead and load the library. Great. Then the only function in the BRRR package is this function called scra. And scra accepts the argument sound, which is just a string or a number specifying the sound to be played. And you can either specify one of the built-in sounds, or you can specify the path to a WAV file that has whatever sound you want. The default is 27, which is Gucci Mane saying brr. And you can, I'll play that here. Brr. Can everyone hear that, or do I need to turn up my sound?
We can hear.
Oh, awesome. You could also play number 11, which is what the function is named after. Or you can put it as 0 and it'll play a random sound from this sort of list of different rap ad-libs. I'm a millennial. Little John was really popular when I was in high school, so I'm kind of partial to if anyone else is. But then another cool thing that you can do is just pull your own WAV files from the internet or wherever, and you can make scra play any noise you want. So I pulled a WAV file from soundbible.com, which just has a bunch of like free WAV files that you can download. And so now I can insert cat meows into my code. I'm genuinely thinking about writing a package called PRRR, P-R-R-R, and just recording a bunch of sounds of my cats to make them play. That could be, another fun with R project to learn how to put a package together. All right, and then just to show how this actually works, if you want to incorporate it into a code, I'm making an example of Flavor Flav, announcing the completion of this function I wrote, sort of modified, called slow function. And so the slow function loops through this function slow math, which basically will take a number, wait 1 second, and then add 2 to that number. It's trivial, but so then slow function, instead of taking a single number, takes a string of numbers, and then outputs all those numbers with 2 added to them. Another thing I learned while building this demo was how to make a progress bar on your code. And so I have this function text progress bar. It's going to make a progress bar that moves across the screen as the code runs. So we can make sure the function's working even though it's slow. And then this little loop goes through the numbers that we've provided in the input, and it outputs the answers with slow math and the text progression bar. And then when it's done, we're going to use Scrap to let us know with Flavor Flav yelling, "Yeah, boy." Okay, so I'm just going to load these functions and then run the slow function. You see my little progress bar? So you can see the little progress bar going across, and then, you know, let's say you had a really long function going that was even longer than slow math and you wanted to do something in the background, then when it's done, Flavor Flav lets you know. And it's just a little joyous way to show that your code is working. So another thing that's fun that you can do is change your options in R to have a sound play whenever you get an error. So for the example here, we can have DJ Khaled consoling us every time we get an error message. So if we just run this code here, options error function equals scraw34. Now I'm going to purposefully run the slow function incorrectly. Obviously, you can't add, the slow function expects numbers as input. B is not a number, so it's not going to like that. Oh, come on, man. What's the issue today, you guys?
They don't want to see us win.
So basically that's what happens when you have an error. For example, I tried to fix the options and I accidentally hit a V after it, and DJ Khaled is consoling me by telling me that they don't want to see us win. We can get it to work now. Huh, I don't know why it's not working after that. Oh, because I have eval equals false.
They don't want to see us win.
Here we go. So that's pretty fun. So anyway, the Scraw package was basically built on top of the beeper package, which is another sound package that lets you use non-rap noises to announce when your code is done. And the beeper package is similar in that it only has one argument that's called sound. And you can either, again, specify the name of these sort of 11 sounds or the number to get different sounds to play when you run the code. So, sorry, I'm just checking the chat. DJ Khaled, yeah, it's my favorite. So now instead we'll load beeper. And you get the classic Mario coin sound when you do beep coin. We can also get other noises like. So that's pretty celebratory, I think, and especially if you're into old school video games, pretty fun. Then again, you can get random beeps by putting in 0. Lame. So again, this time we can run the slow function with beeper. So instead of the scraw at the bottom, we can use beep number 4, and it's going to tell us work complete when it's done. So I'll just load this. And again, run the slow function.
Work complete.
So pretty cute. Then they've also included this sound called the Wilhelm scream, which I didn't know anything about. So I put a link to a YouTube video here. But basically, it's this screaming noise, or this scream that an actor in an old Western video made. And subsequently, they've taken that sound clip and used it for screams in like many other movies. So you hear this particular scream over and over in several different contexts, which I thought was pretty funny. So now instead of DJ Khaled, we'll get the Wilhelm scream for an error message. And then again, we're gonna run the slow function incorrectly.
They don't want to see us win.
It's still DJ Khaled, no. Come on. So, and now instead of DJ Khaled, we get someone screaming when that happens. And actually, I recommend looking at this link. It's pretty funny. You don't realize that the same screen gets looked at or gets used over and over in the movies. So anyway, that's all I've got for the BRRR function. I thought it was pretty fun and silly. I learned how to make a progress bar. I learned how to use my own WAV files to play sounds when my functions are done. And I'm generally inspired by the creator of this package and recommend that you guys all check her out. So, and that we really have to figure out how to get the audio packages on the HPC at MSU so that we can annoy all of our colleagues with our sounds when we get back to working in the office instead of working at home. So that'll be probably my next goal.
Thank you so much, Stephanie. That was a lot of fun. Does anyone have questions for Stephanie?
Was it pretty easy to add your own WAV file sounds for this, or was that kind of an annoying?
No, it was super easy. So I don't know anything about like sounds or like, I don't know, my brother-in-law is actually like a DJ and he makes his own music, and so he has all sorts of crazy sounds and like resources and things like that. I'm thinking about talking to him about getting DJ sounds on here, but I just use soundbible.com. You literally can just Google or just search like, I don't know, cheers, and get like a bunch of, you know, options for different sounds that you can download for free, most of them. And then you just download them, and all I did was, stick them in a folder called WAV files, and then you just call them up. And then also in a big part of the BRRR package, Brooke Watson actually had to go through and change a bunch of MP3s of these sounds into WAV files. So that's all documented in her stuff. So if you have something that's an MP3 instead of a WAV, it's possible to switch it over to be able to use it in the package.
Cool, thanks.
Well, if there are no more questions, we can probably move on to our next speaker. Thank you again, Andrea and Stephanie. Next up, Sneha, would you like to go with the chess package?
Yeah, I can go. Let me just share my screen. Okay. So hi, my name is Sneha. I am an undergrad at MSU studying data science and human bio. So I'm also relatively new to R. I've learned it, like I was first exposed to it like a couple years ago, but doesn't mean I don't like to play around with it. So for the fun with R, I decided to look at a chess package. So last semester when Queen's Gambit came out, I got really into chess. So I thought it'd be fun to see how we could use it through R. So let me talk about the origin of this package. So it's an opinionated wrapper from R based around Python chess, which is like a really cool library created by Nicholas Fiekas, and allows users to read and write PGN files, as well as create and explore game trees, such as the ones seen in chess books. So for people who are not really familiar with chess, so you can play normal moves, but people who are versed in chess and play like regularly know certain like variations and like openings and things like that. So there's like certain things that you can do, and it's based on probability after that. And what PGN files are they're just basically like notations of different variations of when you're playing chess. So something that's really cool is like the PGN files, like there aren't many like ways you can open them, but because of this package now, we can open them in R and see how it plays out. And just when I say variations, I just mean like different openings. There's something called chess variants, which is just like different ways you can play chess, like if you don't put it in like the normal moves, or if you like want to have a theme for chess. So just to know the difference between just variants and variations. And like I said, there's other systems that can be used to open PGN files, but so far, like this one is like this one is used, like R can be used to, this package allows R to be able to be used to open PGN files. So let me just explain a little bit about the basics of chess, because I know some people don't really know, and that's totally fine. So we have a couple of pieces. So we have the pawn, which is all of these pieces here, and they can move 2 spaces or 1 space. And then to get rid of the opponent, they have to move diagonal to kill. Then we have the bishop, which is the one in orange, and that can be played on the diagonals. And that's also how they kill. So they can't move any other way. They can just move on the diagonals. Then we have the rook, which is this piece over here, and it moves along the sides, like horizontally or vertically. We have the knight, which is my favorite piece because it's pretty cool how it can like jump over different pieces. It's the only piece that can do that. So it always moves in like this L shape. So I think it's pretty cool. And then we have the queen. So the queen can do any of the moves I said, except what the knight does. So it can move straight, it can move diagonal, it can move backwards, many cool things. And then we have the king. So the king only moves 1 space at a time. And in order for you to win chess, you'd have to knock it over. And then you also see that there's letters and numbers. So people who play chess regularly with like a timer and stuff, they would be like, oh, I'm going to move this piece to A3 or whichever corresponds to like the letters and numbers. And that's what's used for PGN files when you want to go through different moves. So how to get started. So we have this GitHub file, which is basically, this has the package and like behinds of the package. So I can put this in the chat eventually. But I'm just gonna give an example of like how this works, and then we can go to R and see how it actually plays out. So this is an example of like a PGN text. So if you can see, like there is E5s and C5s. So the numbers that follow the period indicate the turn for each half move. So this means like because white goes first, this would be the move that white goes to, and then this is the move that the black goes to. And then the numbers that follow the 3 periods indicates the second half of the move or the move made by black. So here it's just the move made by black. And then we have parentheses here, and these are just the variations that could have been played or commentators' notes. So all of these PGN files are based on games that happen in the chess world. So this Fischer-Sherman game is a pretty famous game from the 1950s. So the things in the moves in parentheses are possible ways the players could have moved and what the commentators talked about. So if you see here, we see the parentheses, and this can be represented as a tree, kind of a tree diagram, which is what the, so this is what it could be represented as. And when we move on to the package, this tree part can be represented using lists. So if we see here, when you would put this in R, like you'd put all of the different moves in quotation marks, and then the tree part would be put in a list. So like the nested structures can be represented with lists. So we use the list function, and each move is in a string, and each parentheses, which is, like I said, the branch of a tree, is a list. So now I will show you some examples. Can you see my R screen, or am I sharing a different?
You're still seeing your slides.
Okay, let me stop the share and then I'll share my. Okay, so first thing, when you want to, if you want to use this package, you have to install .packages of chess. And if you want, you can also, if you want to install like the GitHub, you would install packages of remotes and then use this to install the GitHub part. And then to explicitly install the Python chess, because it's connected with this R package, you would do chess and then install chess, and then you do library. So let me just run this. Okay, so while this is backing up, I can show you what I've done earlier, hopefully, or not. Okay, I'll just wait.
It did pick a good moment to back up your session.
Okay. Okay, it's gonna restart. So I can just, while it's waiting to restart, I can just explain the next part and I don't have to run it. But so we have the final game of Queen's Gambit, if you wanted an example. So it's called harmon.pgn. And so you would put the file and you put the system.file, and then the package would be chess, and then you would name whatever you want. So the last player that so in the show, basically, last player that the main character played against was Harmon Borgov. So that's why it's called this. So you'd read the game and then you would play it. So, and then if you wanted to play-by-play, you would do this, and then there's a function called forward, and this would tell you like 3 steps ahead, like what was the move played. And the cool thing about this package is it shows like, if this would restart, it shows like the individual pieces. So the pawns are named P, and then so on, depending on like each of the pieces, it would be lined up like a chessboard. So if you wanted to see the variations, you could do this forward 3, and then you could see the variations. So there's different things you can do. There's also the sideline. And then if you wanted to create your own game, so let's say you knew all of the moves like you're practicing with yourself, you can create it by using this game game function, and you can hit with the different moves. So you have the E4, E5, and like I showed in the Fisher game, you could just put it with the lists, and then that would show, you could just basically create your own game. And then if you wanted to move through the pieces, you could just use a forward, and then there's also a backwards if you want to look through it. And then There's also, if you want the pieces to actually look like pieces, you could do something with print with Unicode. So I wish I could show you. Okay, here's an example if you can see below, like what Fisher Sherman. So this was like the whole game. And then if you wanted to see like what the pieces at the end look like, so you can see there's the pawns, and then here's the knight and queen and so on and so forth. And the capital letters are the white pieces and the lowercase are the black pieces. So if you want to learn chess or already know chess and want to see it represented in R, this would be a really great package to use.
This sounds really cool. Thank you so much, Sneha. And actually, if you want to restart your session and pull up some of those snapshots, we can quickly look at it after Kayla's talk. But
Okay,
thank you so much again. Any questions for Sneha before we move on to our final speaker, Kayla? Okay, if not, Kayla, please, we are looking forward to looking at map art now. Take it away. Thank you.
It's cool. So we should all see our studio session. Great. Hi, my name's Kayla. I am a graduate student here at Michigan State. So I'm members of Our Ladies East Lansing. And today I'm going to present how to make personalized map art with R. It's going to be kind of an overview getting started. There's really a lot you can do with this on your own once you get the basics down. So I'm not going to be able to comprehensively cover things, but hopefully enough to get you started to where if you wanted to customize something, you would be able to get there. So to do this, I'm loading 4 packages here. Most of us are probably familiar with the tidyverse, but if you're not, the tidyverse is a collection of packages for reading, cleaning, manipulating, tidying, and visualizing data. If you're not familiar, highly recommended. Go learn it. Anything with data is much easier through the tidyverse.
Sorry, can you make your text a little bit bigger or zoom in on your RStudio?
Yep.
Thank you.
Yeah. How's this? Okay, sweet. Okay, yep. So after the tidyverse, I'm also loading a package called SF, which is a package that basically gives R access to simple features. So it makes working with irregular geometries easy in R, and here it's going to be a big help in plotting our maps. But you can learn more through their documentation website for sure. Another package I'm loading is called OSM data. And this is a package that queries OpenStreetMap for you. OpenStreetMap is an open access map of the world created by basically interested people. If you want to go help out, you can go join right now and start helping gather this map data. So they have an API, and the OSM data package allows you to query through that API, which we'll see throughout the R markdown here. And lastly, I am loading Tigris, which is a package that allows you to download and use the tiger and line shapefiles from the US Census Bureau. So these shapefiles contain legal boundaries, and they have them from different years. If you're really interested, the default, it'll just pull from 2019. But if you really want to go back and start comparing the map as it changes from 2010 to 2019, go for it. There's definitely going to be some overlap between what Tigris can get you and OSM in terms of like data types. It won't be the same data because one is from the US Census Bureau and one is, open source people collecting whatever data. So there's, kind of an overlap in the type, but one of the advantages of using Tigris is it is US Census Bureau data, so it is very high quality, and it can be tracked by year. So that's just a quick introduction to the package we're using. So one of the first things we're going to use is the OSM map data. So we can use the available features function in OSM data to kind of see what kind of data OSM has. So you can see that's really a lot here, much more than I've even bothered looking through at all. But just to give you an idea of the kinds of things you could start marking on a map if you felt like it. So probably one of the most popular tags here though is going to be highway. So we'll use that. But before we start getting into the highway data from OSM, we need to define a boundary box. And we can do that with the getBB function from the OSM data package. So here I am defining our boundary box as East Lansing, Michigan. And this will get you the longitude and latitude values that kind of box your area in. So it's just this little data frame returned to you. And once you have some kind of boundary box defined, you can use those or that boundary to pull data from within that boundary from OpenStreetMap with the OSM data package here. So what you do is give your boundary box to this OPQ function. This is the query function. So basically this is querying the OpenStreetMap API and with the, again, boundaries you've defined. And then these add OSM feature is modifying that query to kind of tell it which parts. So when I send this query, I don't want it to give me back the information from all of these features. I am only looking for highway, which is different types of roads, which we'll see in a second here. And then this last part of the code, this OSM data SF, is telling the OSM package to give me the data back in the form that SF understands. Again, SF is the package we're going to be used to help plot this data, so it needs to be understood by SF. So there are other formats which we're not going to worry about here. For this plotting, we always want it in this format. Okay, so I made that query. I just will warn you, I know we have some Chicago R ladies here. If you're gonna go highways from the whole area of Chicago, this query might take a few minutes. I haven't played with it too much, but I will tell you it takes a second to query and get data back, and the bigger your area is, the longer that query is gonna take. So this query, just all of highway, what does it return? I'm just gonna plot it with ggplot and SF. The object we've created here, highways, has the data for the road stored in this OSM lines. So that's the data I'm plotting. And I've changed the color by type of road here. So we can just see how many types of roads you get when you query just for highway. You can see there's really a lot here. This is a very dense map of East Lansing. And you can imagine if you do, Chicago or Boston, you're gonna get even more kind of crammed in there. So it might be useful to sometimes, okay, chat. Yes, I will give this markdown to Janani, and I am assuming Janani will put this R markdown document in our GitHub repo. Okay, great.
Yeah, I'm adding
so
it as we speak. I'll share it with you all.
Okay, fantastic.
I have another question, Kayla. What does the like highways object look like itself after you query? Like, is it just a data frame or?
Highways is what I called it. Okay, so you can see it's kind of a special object that OSM data creates. So there's not like a perfect thing I can compare it to you for, but basically it's a big object that contains more objects. So one of these is the box. So this is the boundary box that it's associated with that we define for East Lansing. The OSM lines data is what I'm plotting. You can see that there's points and polygons, which if you pull other types of data might be, more where your data is going to be stored. Somebody's queried like all the supermarkets in Chicago, for example, that would be probably something stored under GM or OSM points. But for this, OSM points is Okay, not exactly sure what that is doing at the moment.
That's okay. I just was curious about what the structure of the object was.
Yep. So basically it'll have like the different geometries that are needed to plot it. Polygons, for example. I have no, most of these are NAs, you can see. You're mostly going to be interested in lines, but maybe for some of the other things you query. Yeah. And then you can also see like the actual query, I believe it sends to OSM if you want to look at that from that object. So basically you're just looking for the actual data object in the query object to plot, which is why you'll see this OSM lines a lot here. Okay, so like we said, this is pretty dense. You might not want every single thing for any given feature. So remember we checked available, what is that, features? Yeah, available features. So all of these are called features. Within each feature, you have often multiple more values. So for example, on highway, we can maybe apply less, make this a less dense map by choosing only certain road types. So you can check available tags for the particular feature highway. And this is all the different kinds we have here, which would be plotted up here with the different colors. So maybe if you're plotting a larger city or area, you only want the biggest or the main roads. So that's kind of what I picked out of here, of these available tags in highway. So it's the same query as above, except for I added this value argument and basically listed the types of roads I wanted to plot. And when we plot that, we can see it's a much less dense and you only plot the things you want to plot out of the whole data query. Getting a bit more specific, like let's say you don't want to just say, Chicago or East Lansing. You can define your own boundary box. So again, that's just a matter of making your little data frame with your maximum, minimum longitudes and latitudes. I got these just by going to Google Maps, and if you just click anywhere on a map, you can see this little box pop down here with the latitude and longitude values you can use. So kind of defining that for an area of campus is what this campus boundary box is. And then since I am trying to plot Michigan State's campus, I thought, maybe I want footways in there as well, because there's a lot of sidewalks and paths on the campus. So I made two different queries so that I could have campus sidewalk and campus roads. Doing this allows me to plot them separately in the map and therefore color them, size them, etc. differently when I plot them. So these kind of queries, if we go and plot both of these queries, so here I'm plotting campus roads and campus sidewalks. As I've said, I changed the size of each, and then this gives you this output as the campus map. So now we can see all the roads and sidewalks on campus. I've just given a manual color. A couple of the other things that may be important is this chord SF. All I'm doing is specifying for the plotting to cut off anything that's outside the boundaries, because when you're pulling road data, you kind of just pull the road and it cuts off, wherever the road cuts off. So using this SFXLM and using this expand equals false particularly means that all those kind of like end of roads that are going to be outside your box are just cut, so you have a nice square or rectangle. The rest of this is just saying don't plot any axes or anything. It's basically theme void. Okay, so now we have like a basic campus map here. But one thing about MSU's campus that I really enjoy is we have the Red Cedar River flowing through it. Right here you can kind of see actually because of how our sidewalks are structured. But if we actually want to include water features in our map, we can do that with Tigris. You could possibly figure out how to do it with OSM. I think Tigris is better in terms of resolution. And like I said, it's very high quality because it's US Census Bureau. So we're going to use Tigris to try and get our Red Cedar River on this map. So the first thing we're going to do is use the Tigris package to pull counties from the state of Michigan. And then we're going to use this street crop function to crop the county lines from the state of Michigan just to our area. This kind of is unhelpful because there's not multiple counties in my plotting area, of campus, but it'll be useful for you to create a background if you are, again, plotting a larger area. So for me, this is basically, my boundary box of county lines is a plain gray background. It's okay, we now have this background, which I can use to cut out with the water. So we're gonna use some custom code here to pull the water boundaries from the US Census Bureau. So what that looks like is just, you would just have to replace your minimum and maximum latitudes here to do this. This looks complicated, but I promise it's really a matter of just like plugging your thing into this custom function. But once you do that, we can see that we have, pulled our water from Tigris, and plotting that, this is what the red seaver looks like through Campus. Now that we have the water shape, we're going to carve that out of our county's background. So again, I pulled county data to just create this plain background, plotted the river, and now we can carve this out of our background. So how we're going to do that is this erase function, which is again just custom code that you just plug in. And when you plot this, I've now taken this county's gray background that I made originally and just like carved out the water polygon to put the river in there. And once you've done this, as with all ggplots, color is easy to modify. So I've just made it dark with the yellow here. And I'm plotting basically the same, using this geom SF to plot the county's MI, which I created here. Okay, so now we have a roadmap and we have a map where I kind of put the water in only. So we can put those together. So here I'm mapping my county's MI, my campus sidewalks, my campus roads, and then this is just the part that makes it a nice square. And we are plotting them all at once to create one map of campus where we have kind of the stark background, our roads and sidewalks in light gray, and we can now see our river plotted in yellow nicely here. Again, the colors are easy to change, just the code can be replaced with whatever color. And one last thing I kind of wanted to put on here is if you wanted to mark one, specific place. For our lab group, our place on campus is the MSU Dairy Store. That's our favorite meeting place. So I thought I would mark that on our map. And again, you can just go to Google Maps, click somewhere and get the exact longitude, latitude, coordinates, and then just use geom point to add that point to your map. So you can see this yellow dot here for our MSU Dairy Store. And obviously you could change the shape, color, everything with this. It's a ggplot, so the normal aesthetics and colors and shapes and features you can play with is all there. Okay, so let's say you're happy with this map. This is your personalized done map. The last thing you want to do is save it. So we'll call it final map. And you might want to print this out, add text, overlap images in something like Google Slides or ImageMagick or Inkscape, anything you want, but you're going to have to export this in high resolution for it to look good. So we're going to use ggsave for that. You can save it to any file name you want. You're going to have to define a width and a height, which will always be measured in units, which I think the maybe default is inches. I always specify it though, just to make sure. So this would be a 24 by 24 inch size PNG that we're saving here. It's very important to put this DPI argument though, to make sure you're not saving a 24 by 24 inch super blurry piece of art. This DPI will save it at 500 dots per inch, which will be high enough resolution to do things with. And that's mostly the arguments you're gonna have to worry about with ggSave. So again, once you have this PNG saved, you can go ahead and open it up. One thing people have done is just overlaid text on it. So you know, the image would just be exported, opened in Google Slides, put your text here. Really anything can be done at that point. I added points. If you are very interested in this, I've put a couple of other blog posts at the bottom of this art markdown. One in particular is Esteban Maro's blog, where he will go over some of the things I've shown. But this adding personal mobility, you can pull Google Maps data from your phone and go ahead and plot the routes you commonly take in your city. So there's really a lot to customize that you can play with here. And lots of blog posts to list or look at. So highly recommend checking some of those out to get more cool customizable things to add to a map. I think that's all I have. So I guess if we have any questions or if I missed any in the chat.
This was amazing, Kayla. Thank you so much. We don't routinely play around with maps, but you gave us the right motivation with the dairy store and everything. So
Great.
This is really cool. Thank you. Anyone, do you have questions for Kayla?
I'm just really excited to, I didn't realize you could separate it into like the specific like campus. I want to do that for all the various million universities that I've gone to.
Yes, the separation is going to be really good for the coloring and the alphas, you know, the darker, lighter showing up.
So actually, since we are towards the end of our meetup, if anybody has questions retrospectively on any of the 4 talks, please feel free to ask our speakers. Or if you want to start a discussion related to any of these topics, that's cool too. Okay. Wei has a question. Do you have to manually put in the longitude and latitude of each place in the map?
It depends. Originally, I just used, you know, this getBB function, which is going to automatically pull those longitude and latitudes for you. But this is going to be more for cities, you know, that have a name, you know, of direct place. So it's only when you want to get more specific, you know, I only want this area, that you're going to have to manually define that boundary box.
What's the function you mentioned? To automatically showing this?
Yeah, so the getBB function is from the OSM data
HBB?
package. Yep, getBB. And then you just, you know, you could put Chicago IL in here. It's a world map, so you should be able to use, you know, London, England. I can't promise that the data will be the same everywhere, because like I said, this is an open source project, so the data depends on the people putting it in there. But I think their map is pretty complete. You should at least be able to get the road map of most places, if not some of the more detailed, you know, here there's every little service classified, unclassified type of road here. So some of those might be undocumented in more rural areas, but for the most part, you know, cities are going to be pretty easy to just use this getBB function.
Okay.
If not, though, I didn't find it too hard to just open Google Maps and kind of, you know, just click and pull them.
What if I just want to make a map for some countries or continent? It's the same principle?
I believe so. I have not tried. Let's see if you just want to do Canada. Apparently you can just put in a whole country there, and it'll pull this for you. So
Awesome.
I think, yeah, anything that you can name and put in here. we'll work to give you your
Okay.
boundary box.
Great. Thanks.
Yeah.
All right, before we take further questions, I just want to remind you that if any of you are interested, you should definitely check out the user global conference that's coming up this July. We are, the registration has just started. It started this week. And we do have waivers for people who are underrepresented in data science and in R programming. So if you need any more information about this conference, please join our meetup next week. So this is going to be a joint meetup by several Our Ladies Plus groups from across the world. Andrea is also going to be there next week. So we have people from Australia, Europe, Africa, South America, and from the US. And East Lansing has dibs on at least 50 seats, so please do sign up. User is going to be a really fun conference. And this time around, the conference is going to happen in 3 different languages, and it's going to be time zone friendly, and it's going to be truly global in every possible way. So we are looking forward to a lot of diverse representation. All right, with that, we can get back to any questions for our speakers. And Andrea actually said she has fixed a little bug, or actually it was not even a bug. She just had to load something and now it works. So
No, it's just to end this on a more positive note, because things break in online. It's like, how? But I just to explain what happened. I was testing with a DevTools load all package that loads the package without installing it, and I made the push with that. So if you install it with that, it will not find anything because it's only local. So I had to change it to a library call. So I just wanted to just show you how it works a little bit more easily. This should be my whole. So for example, I was testing this. So you have any. When I was a kid, I always tried to understand the Beatles song. So it's like something that I did. So for example, you put the target language and you say search, and it just goes to the API, goes back. And the Google Translate API does this. So if you wanted to do it in French, it just will do it. But sometimes it doesn't understand what you're asking for. So maybe, I don't know, like, hey, right, I just have an idea. These kind of things. So it's cool because this is something that I Google a lot, like what is the meaning of this lyric? So I'm just centralizing it. So for some, I don't know, languages that you don't understand, something like that. And it will give you back tables. So it was just to show you that it does work indeed. It's not that I didn't make it work. And if you do not put a target language, for example, here, it says it will return a message saying like you didn't have a target language selected, so it will just return the lyrics and it's a table. And if you do have a target and you have this, this, it will just give you the 2-column table with the translation. So it was just to make sure that that you do watch it work. So I am. Just because you can reinstall if you are interested. It's in the repo. And
by the way, for your error message, Andrea, now after Stephanie's talk, you should, if they don't give a default language, you should make it make weird sounds. So they do add a language.
I didn't understand that. I'm sorry.
No. I just said you can add sounds to the error message based on what Stephanie showed us today. If they don't add a language.
I do use that package. I love that package. The Mario Bros sound just makes me happy, like when it stops.
Absolutely.
So thank you very much. And thanks for the opportunity to watching you that working, like the package working.
That's
I
very
had
cool.
one friend
Thank you.
in high school who loved reggaeton, and your package would have been super useful for me then.
Yes. What happens with reggaeton is that it will have like some lines. It will be in Spanish and some others will be in English. And the Google Translate, the offline detector of languages, shows you exactly the language of each line. So you are not going to make. So I just took the most frequent language to be as detected. So it will translate it to the most frequent detected language. But that's cool with music that has many languages in the lyrics. That happens a lot.
That's really cool, actually. Sneha, do you want to show us anything, or are we good to close?
We're good to close. I think
Okay.
the GitHub shows so
Okay, all right. So I've added the links to all the presentations and the repositories from today. So please do check it out. It was indeed a lot of fun. Thank you so much for closing our Spring 2021 series on a high note. Thanks, Andrea, Stephanie, Sneha, and Kayla. And one more news that I'll again share on our Slack. But I would also like to announce once again that Stephanie and Kayla have joined Our Ladies East Lansing as co-organizers. So also congratulations to them. We are very happy to have them on board. So with that, thank you so much, all of you. Looking forward to seeing you next week or, well, next semester. Have fun. Bye-bye. And stay safe. Bye-bye.